Pressurization begins with an overview, followed by controls and indicators, system description, and normal operation. The electronic pressurization controller regulates the pressurization by opening and closing outflow valves. The area in blue is pressurized. The pressurization controller produces very comfortable altitudes during all phases of flight. Now, let's look at the controls and indicators for the pressurization system. The controls and indicators are located on the overhead panel. The cabin altimeter differential pressure indicator provides cabin altitude and differential pressure readings. The short pointer on the inner scale is the cabin altimeter. It indicates cabin altitude in thousands of feet. The long pointer on the outer scale is the differential pressure gauge. It indicates the differential pressure between the cabin and ambient, displayed in PSI. The cabin rate of climb or descent is displayed on this indicator in thousands of feet per minute. Note the pressurization differential limit of 0.125 psi for takeoff and landing. The altitude horn cutout switch is used to silence the intermittent warning horn. The pressurization system has three modes of operation: automatic, standby, and manual. In manual, the AC or DC position is used to select the power source for the main outflow valve. The check position is used to test system operation. These controls and indicators are used in the automatic mode. These controls and indicators are used in the standby mode. This section allows the crew to manually control pressurization. We will now discuss the pressurization system description. The electronic pressurization controller maintains pressurization by positioning the main outflow valve. The main outflow valve is electrically powered. The AC motor is used during automatic or manual AC operation. The DC motor is used during standby or manual DC operation. Two positive pressure relief valves located on either side of the main outflow valve limit differential pressure to a maximum of 8.65 psi. A negative pressure relief door opens to prevent external pressure from exceeding internal cabin pressure. The automatic mode requires two inputs by the flight crew: the planned flight altitude and the landing airport elevation. The controller compares these inputs and determines the cabin altitude requiring the lowest differential pressure. For flight altitudes below 28,000 feet, cabin altitude is based on a 7.45 psi or less differential pressure. For flight altitudes above 28,000 feet, cabin altitude is based on a 7.8 psi or less differential pressure. Now, let's discuss the steps necessary for a flight using the automatic mode. We will take off from a field elevation of 20 feet and cruise at 30,000 feet. We will land at an airport with an elevation of 900 feet. Barometric corrections are provided to the automatic mode from the baro set knob on the captain's altimeter. The flight altitude selector is used to set the cruise altitude in the flight altitude window. Push in and rotate. In this example, set 30,000 feet. The landing altitude indicator and the dual selector knobs are used to set the landing field elevation. The outer knob sets the thousands of feet. The inner knob sets the tens of feet. In this example, set 900 feet. With the airplane on the ground, the outflow valve is driven full open with ground selected. The main outflow valve position is shown on the indicator at all times. Verify that the mode selector is in auto. Selecting flight on the flight ground switch causes the outflow valve to close. This gradually pressurizes the airplane to about 200 feet below departure airport elevation. Cabin altitude follows airplane altitude. As the airplane climbs, the cabin climbs proportionally. If the airplane levels off during climb, the cabin altitude levels off. When the airplane resumes its climb, the cabin resumes its climb. The amber off-schedule descent light illuminates if the airplane descends before reaching the selected flight altitude. The air conditioning annunciator and master caution lights also illuminate. When the off-schedule descent light illuminates, the pressurization controller plans for a return and landing at the departure field. The controller sets the cabin altitude for landing at the departure airport without any crew action. The controller disregards the landing altitude input when the off-schedule descent light is illuminated. During cruise, the automatic controller maintains a cabin altitude of 300 feet below landing airport elevation, if possible, without exceeding the maximum differential pressure. For flights below 28,000 feet, the controller maintains maximum differential pressure of 7.45 psi. For flights above 28,000 feet, the auto controller maintains a maximum differential pressure of 7.8 psi. In our example, at 30,000 feet, the cabin altitude is about 5,000 feet, since the cabin cannot be maintained at landing altitude minus 300 feet without exceeding 7.8 psi. Let's continue with our flight profile. During cruise, cabin altitude is held at comfortable and nearly constant cabin altitude during turbulence. However, if the airplane begins an unscheduled climb, the cabin altitude can only be held constant until a differential pressure of 7.90 psi is reached. Then the cabin altitude climbs. During descent, the automatic system reduces cabin altitude proportionally. If the airplane levels off, the cabin levels off. To avoid a pressure bump on landing, the cabin is pressurized to 300 feet below the landing airport elevation. At touchdown, the cabin altitude changes to 200 feet below airport elevation. On the ground, positioning the flight ground switch to ground opens the outflow valve and depressurizes the airplane. Answer B is correct. Selecting ground after landing opens the main outflow valve. This depressurizes the airplane. Selecting flight on the ground pressurizes the cabin to 200 feet below airport elevation. This prevents pressurization bumps during takeoff. The standby mode will be discussed next. The green standby light is illuminated when the pressurization system is operating in standby. The flight ground switch functions in standby the same as in auto. Barometric corrections are provided to the standby mode from the baro set knob on the first officer's altimeter. The standby mode requires two flight crew inputs, cabin rate and cabin altitude. The cabin rate selector sets the rate of change from 50 feet per minute at decrease to 2,000 feet per minute at increase. The normal position is at the index, which is 300 feet per minute. Each phase of flight requires a different cabin altitude selection. It is set using a dual knob like the landing altitude knob. The cabin flight altitude placard is used to determine the cabin altitude. Let's discuss the steps necessary for a flight using the standby mode. We will take off from an airport elevation of 1,040 feet and cruise at 35,000 feet. We will land at an airport with an elevation of 20 feet. Ensure the mode selector is in standby. The green standby light illuminates. Check that the cabin rate is set at the index of 300 feet per minute. In order to pressurize the airplane before takeoff, the cabin altitude selector is set 200 feet below departure airport elevation. In our example, 840 feet. After engine start, place the flight ground switch to flight. Observe that the cabin differential pressure is at approximately 0.1 psi after the main outflow valve closes. The panel is set for takeoff. Each phase of flight requires a different cabin altitude. Use the cabin flight altitude placard to determine the cabin altitude setting for the cruise altitude during climb. For our planned flight altitude of 35,000 feet, enter the flight altitude placard at 35 and read directly above a cabin altitude of 7.2. Set the cabin altitude indicator to 7,200 feet. Just before descent, a new cabin altitude must be set to 200 feet below landing airport elevation. With our airport elevation of 20 feet, a negative 180 feet is set in the cabin altitude window. This ensures a pressurized cabin during landing that does not exceed the 0.125 psi limit. After landing, placing the flight ground switch to ground opens the outflow valve and depressurizes the airplane. If a failure occurs while operating in the auto mode, the controller automatically switches to standby. The amber auto fail light illuminates, causing the air conditioning annunciator and master caution lights to illuminate. The green standby light illuminated indicates the pressurization system is operating in the standby mode. Answer B is correct. With the cabin rate selector at the index position, the cabin rate of change is 300 feet per minute. Answer B is correct. When operating in the standby mode in flight, the cabin altitude must be determined from the cabin flight altitude placard. For 33,000 feet, cabin altitude should be set at 6,400 feet. Now, let's look at the manual mode. The manual mode is used as a backup for a failure of the automatic or standby mode. The manual mode is also used during non-normal procedures, such as passenger evacuation or ditching, as it provides positive outflow valve positioning. The green manual light illuminates when operating in the manual mode. Selecting manual AC or manual DC determines the electrical power source for the main outflow valve. The AC motor operates at about twice the speed of the DC motor. The main outflow valve is repositioned using the outflow valve switch. The switch is spring-loaded to the center power off position. Recall that the valve position indicator functions in all modes. Let's now discuss normal operation of the pressurization system. The pressurization system is normally operated in the automatic mode. During cockpit preparation, set the planned cruise altitude in the flight altitude window. Set the landing field elevation in the landing altitude window. Verify that the auto fail light is extinguished, and ensure that the cabin rate selector is at the index. Set the cabin altitude indicator 200 feet below landing field elevation. Check that the flight ground switch is in ground and the mode selector is in auto. The pressurization system is now set for engine start. After engine start, position the flight ground switch to flight. Recall that the main outflow valve closes, pressurizing the airplane. No further crew action is required until after landing. After landing, position the flight ground switch to ground. The main outflow valve opens, depressurizing the airplane. This completes the presentation of the pressurization system. In this module, we will cover non-normal system indications and procedures for air conditioning, pressurization, pneumatics, and ice and rain protection. Let's first look at the procedures for the air conditioning, pressurization, and pneumatics systems. These lights monitor the pneumatics and air conditioning systems. The amber lights cause the air conditioning annunciator and master caution lights to illuminate. We will study each non-normal indication and procedure in greater detail. The airplane is rapidly depressurizing. Loss of pressurization is noticed by abnormal readings on the cabin altimeter and the cabin rate of climb indicator. Some ear distress may also be noticed. The intermittent cabin warning horn will sound when the cabin altitude reaches 10,000 feet. Silence the horn by pressing the altitude horn cutout switch. Recall items are then accomplished. Refer to your manual and review the rapid depressurization procedure with special attention to the recall items. If unable to control pressurization with the airplane above 14,000 feet, an emergency descent must be initiated. Announce the emergency descent. The captain will advise the cabin crew of the impending rapid descent. The first officer will advise air traffic control of the emergency descent and obtain the area altimeter setting. Refer to your operations manual and review the emergency descent procedure. Air conditioning smoke is recognized by the smoke entering the passenger cabin or into the cockpit from the air conditioning outlets. Refer to your operations manual for the air conditioning smoke procedures. Answer A is correct. If the smoke stops, the source has been isolated. Continue the flight with the right pack switch off and the isolation valve closed. A duct overheat light illuminates. This indicates an overtemperature in the supply duct. The air mix valves automatically drive to full cold. Corrective action is to position the temperature selector to a cooler temperature. Reset the system by pressing the trip reset switch. A pack trip-off light illuminates. This indicates an overtemperature in the air cycle machine or supply duct. The pack valve automatically closes and the air mix valves drive to full cold. The corrective action is to position the temperature selector for that pack to a warmer temperature. The system may be reset after the pack has cooled by pressing the trip reset switch. The dual bleed light is illuminated. This indicates that there is a possibility of back pressuring the APU from an engine bleed source. This is a normal indication for engine start, and engine thrust should be limited to idle with the light illuminated. Recall that this could occur if the number 1 engine bleed air switch is on and the APU bleed valve is open. Also, a dual bleed condition will exist if the isolation valve is open, the number 2 engine bleed air switch is on, and the APU bleed valve is open. Positioning the APU bleed switch off will extinguish the dual bleed light. The bleed trip-off light illuminates. This is caused by either an overpressure or overtemperature in the pneumatic duct. Either condition signals the affected engine bleed air valve to close. After adequate cooling, pressing the trip reset switch will reopen the bleed valve and the bleed trip-off light will extinguish. A wing body overheat light illuminates. This indicates a bleed air duct leak somewhere along the pneumatic manifold in the fuselage, engine strut, or wing leading edge. Position the isolation valve switch to close and the engine bleed switch on the affected side to off. This action removes all sources of bleed air to the failed duct. The light will extinguish when the temperature in the duct has cooled. An equipment cooling off light, the master caution and overhead annunciator lights illuminate. This indicates the loss of airflow from the selected fan. The supply and exhaust fans operate in the same manner. The corrective action is to position the equipment cooling switch to alternate. It may take a few minutes for the equipment cooling off light to extinguish. The auto fail light illuminates, causing the air conditioning annunciator and master caution lights to illuminate. Illumination of the green standby light confirms the pressurization controller has automatically switched to standby. Positioning the mode selector to standby will now extinguish the auto fail light. Use the cabin flight altitude placard to determine and set the cabin altitude. An unscheduled pressurization change is indicated by unreasonable changes in cabin altitude. Ensure that sufficient bleed air is available to the packs by increasing thrust. Corrective action is to select standby on the mode selector. Use the placard to determine and set the cabin altitude. If unable to maintain pressurization in standby, select manual AC or DC depending on the electrical power sources available. Remember, the AC motor moves the outflow valve at twice the speed of the DC motor. Now, use the outflow valve switch to reposition the main outflow valve. The off-schedule descent light illuminates. This indicates that the airplane has descended more than 1,000 feet before reaching the altitude set in the flight altitude window. The airplane will automatically pressurize to the departure field elevation. If not landing at the departure airport, the flight altitude indicator should be reset to actual airplane altitude.